In this video, we take a look at how to implement the merge sort algorithm. So note that with the merge sort, the exam board require you to know the main steps of the algorithm, understand any prerequisites, apply the algorithm to a dataset. You should be able to identify it from its code, read and trace it, and you should be able to write the code for this in the exam. So a merge sort can sort a dataset extremely quickly using divide and conquer. The principle of divide and conquer is to create two or more identical subproblems from the larger problem, solving them individually, and then combine their solutions to solve the overarching problem. With the merge sort, the data set is repeatedly split in half until each item is in its own list. Adjacent lists are then merged back together, with each item in the sublist being entered into the correct place in the new combined list. A merge sort is suitable for any dataset but works best with larger ones where memory is not a concern. However, the time taken to perform the sort should be minimised. It is ideal for parallel processing environments where the concept of divide and conquer can be used. Here's an illustration to help you visualise a merge sort. Here is the pseudocode for a merge sort. You will notice this is the first algorithm where we're using a call to a function, in this case merge. The merge function will be used multiple times, taking in two lists each time, comparing the items within them, sorting them into a new single list, and then returning this new list back. You will probably also have noticed there's a lot more code here than we've seen up till this point. This is because the merge sort is a more complex algorithm than the four we've covered so far. To fully understand this algorithm, we're going to add an additional level of abstraction, step back from the pseudocode and start by looking at some simple structured English. So here's the pseudocode for a merge sort using simple structured English. Steps 3 to 6, shown here in blue italics, are the steps that take place inside the merge function. Pause the video for a moment and just read through the steps shown here. We're going to step through each stage from the simple structured English and explain what the associated pseudocode is doing. So we start by initializing several lists. Items is the initial unsorted data set, which in this case contains 4 American states. In this example, we're choosing to store the initial data set in a list, and the pseudocode assumes we're working with lists that are supported by most programming languages, such as Python, VB and C#. There are also 2 additional empty lists, item and list of items. It will soon become apparent what we're using those for. When implementing this algorithm, step 1 can be achieved by putting each item into a new list one at a time. This is a simple optimization that is really worth implementing. Examiners will of course expect you to understand that a merge sort splits the dataset repeatedly until each item in its own list. So each time round our for loop, we take one element from the original list called items, put it into a new list, item as the only piece of data, and then put that single item list into lists of items. What we've effectively done is taken the original dataset, the single unsorted list items, and created a new list called list of items, which itself contains a set of lists, each of which contain a single item. Now it might feel like we've cheated a bit here, but this is a perfectly valid way of implementing step 1 from our structured English. The end result is the same. Every item from the original list is now in its own list, and those lists have been contained inside list of items in their original unsorted order. So next we take two adjacent lists and start with the first item in each. So now we call the merge function and pass in two lists as parameters as part of the function call. List of items index and list of items index plus 1. The first time we call this function, it passes in indexes 0 and 1, the contents of list of items shown in green. These lists are copied into the local lists of the merge function, list 1 and list 2, as they're passed by value. You will notice the call to the merge function occurs inside a while loop. We'll come back to that later. In effect, we're going to keep calling the merge function again and again until eventually list of items comprises one single list that contains all the items in the correct order. You will also notice every time we enter the merge function, we initialize a few local variables. There's new list. This starts off as an empty list each time we enter the merge function. Eventually, it will contain the result of merging the two lists we passed in, list 1 and list 2, which will then return back out of the function. Index 1 and index 2, these are two local variables and they're set to 0, and we're going to use them to keep track of where we are in the respective local lists, list 1 and list 2. We now compare the first items in list 1 and list 2 with each other. This is represented by the if-else-if statement in green. There are three parts to this if statement, depending on whether the item from list 1 is greater than, less than, or the same as the item from list 2. Note how we're comparing the first item from each list, but at the moment there's only one item in each list. Of course, this will change as the algorithm plays out. Depending on the outcome of the previous comparison carried out by the if statement, we append the lesser of the items into the new list and update the appropriate tracking variable index 1 or index 2. In this case, we're comparing list 10 Florida with list 20 Georgia. Florida is less than Georgia, so the second part of the if statement is executed, which appends list 10 Florida to the new list. We have to repeat this process until all the items from one of the lists have been put into the new list. We achieve this by closing the previous if statement inside a while loop. The while loop will keep executing the comparison code as long as both tracking variables, that's index 1 and index 2, are less than the number of items in their respective lists. In this situation, the while loop will only execute once, as all the items from list 1 Florida have already been put into the new list. Just before we exit the merge function, we need to append all the items from the list that still contains items that we haven't yet moved over into new list. We achieve this using an if-else-if statement and the tracking variables index 1 and index 2. Once we figure out which list we need, we execute a for loop to iterate through its remaining items and append them to new list. The result, as you can see, is that the new list is a single sorted list containing all the items from the two original lists that were passed into the merge function. Remember, the merge function takes in two lists and returns a single list containing everything from the original two but sorted. So the final thing we do before we move on to the next step is to return the new list back to the part of the main program that called it. The code shown here copies the local merge function new list and places it back into another list in the main program, also called new list. And this is fine because each has a separate scope. As we exit the merge function, only the new list is returned. So back in the main program, we now need to replace the original two adjacent lists that we passed into the merge function from list of items with the new list that's just been returned. To do this, we copy new list into list of items index, which is currently index 0, and we delete list of items index +1, which is currently index 1. We've effectively replaced two elements from list of items with one and moved everything else down one index. One of the main advantages of using lists in a merge sort is that we could execute a simple delete operation on list of items to get rid of the element we didn't want, and all the others automatically move down one spot. If we'd chosen to use a static array to store items, we'd have had to copy each item down one element at a time, replacing the previous contents, and this is the approach we took with the bubble sort. Once again, it goes to show how one algorithm can have many different implementations. Well, that is the main essence of the merge sort algorithm. Of course, we repeat the whole process of calling the merge function again and again, each time passing in two lists from list of items. Just before we check the while loop again, we increment the index variable. So in this case, it goes up from 0 to 1, meaning we'll now pass in the two lists shown in green at positions 1 and 2. And we repeat this process until we reach the end of list of items. Finally, we repeat what we have covered so far until list of items contains only a single list. When it does, we know it will contain all the items from the original data set in order. Note how each time we fall back to the outer while loop, we need to reset index back to 0. Here is some syntactically correct Python code that demonstrates the merge sort algorithm in practice. Let's trace it as we have for the previous algorithms and see how it works step by step. We're going to keep the simple structured English in the top right corner so you can follow where we are in the overall algorithm. We start with the unsorted list of 4 American states called items. We do this for simplicity. In reality, the entire algorithm would likely be encased in a function, and we would call it by passing in the original unsorted list as a parameter. And we also create two empty lists, list of items and item. We enter a for loop for n in range len items. The length of the items list is 4, and in Python this means values 0 to 4 but not including 4 itself. Effectively, this means the for loop will execute 4 times, iterating through elements 0 to 3 in the items list. We now assign the contents of items n to the item list. As n is currently 0, we copy Florida into element 0 of the item list. We now append the contents of the item list to list of items. Having reached the end of the for loop, n automatically increments from 0 to 1. We repeat the process 3 more times. Every item from the original list is now in its own list, and these have been contained inside list of items in their original unsorted order. We now check if we need to enter the outer while loop. There's just one condition that has to be met to enter the while loop. So let's look at the length of list of items. That's 4. 4 is not equal to 1 is true. So the condition has been met. So we enter the outer while loop. We assign index the value of 0. We now check if we need to enter the inner nested while loop. Now there's one condition that has to be met to enter this while loop. Index is less than length of list of items minus 1. Well, index is 0. Leng list of items minus 1 is 3. So 0 is less than 3 is true. As the condition is true, we enter the inner nested while loop. We now call the merge function, passing in two lists as parameters as part of the function call. Index is currently 0, so we pass in the contents of list of items element 0 and element 1. These lists, shown in green, are copied into the local list of the merge function list 1 and list 2 as they're passed by value. So inside the merge function, we initialize three local variables. New list, and this starts off as an empty list each time we enter the merge function. Remember, eventually it will contain the results of merging the two lists we passed in, list 1 and list 2, which will then be returned back out. And we also initialize index 1 and index 2, two local variables set to 0, and we're going to use those to keep track of where we are in the respective local lists. We now check if we need to enter the while loop. There are two conditions that need to be met to enter the while loop. Index 1 is less than length of list 1. Well, index 1 is 0 and length of list 1 is 1. And also index 2 is less than the length of list 2. Well, index 2 is 0 and length of list 2 is 1. So 0 is less than 1 is true, and also 0 is less than 1 is true. Both conditions are true, so we enter the while loop within inside our merge function. We now check which part of the if-else-if statement that we have to execute. First, we check the condition list 1 index 1 greater than list 2 index 2. Well, index 1 and index 2 are both 0, so what we're asking here is Florida greater than Georgia? Well, that's false. The condition's not been met, so we move down to the elif section. So now we check the condition list 1 index 1 less than list 2 index 2. So we're asking here, is Florida less than Georgia? Well, that's true. The condition's been met, so we enter this part of the if-else-if statement. We now append the contents held in list 1 index 1 to new list. As index 1 is 0, we append Florida into new list. We also increment index 1 up one value from 0 to 1. We fall back to the while loop and check if we need to enter it again. So index 1 is less than length list 1. Well, index 1 is 1 and the length is 1. So we've got 1 is less than 1. Well, that's false. It doesn't really matter what the second part of the while statement condition is here, because we've got a false. We've got a false and true. In other words, both conditions are not true. So we're done with the while loop for now, and we can move on. So we move on now to appending all the items from the list that still contains items, and we hit an if-else-if statement. So first we check the condition index 1 is less than length list 1. Well, index 1 is 1, the length of list 1 is 1, 1 is less than 1 is false. The condition has not been met, so we move to the elif section. So we check index 2 less than leng list 2. Index 2 is 0, len list 2 is 1, 0 is less than 1 is true. The condition has been met, so we enter this part of the if-else-if statement. We now hit an inner nested for loop, which executes for range index 2 to leng list 2. Well, index 2 is 0, and the length of list 2 is 1, so that's range 0 to 1. In Python, this means values 0 to 1, but not including 1. Effectively, this means the for loop will execute once and simply append Georgia from list 2 into new list. Before we exit the merge function, we need to return new list back to the original part of the main program that called it. The local version of new list is returned and ends up in a list in the main program, also called new list. And remember, this is fine because each version has a separate scope. As we exit the function, the following local variables lose scope and cease to exist: list 1, list 2, index 1 and index 2. We now assign a copy of new list to list of items index. As index is 0, we copy new list into list of items element 0. We now delete element index plus 1 from list of items. Index plus 1 is 1, so we delete list of items element 1. As we're using a list data structure, the items in list of items 2 and list of items 3 are automatically moved down one spot into list of items 1 and list of items 2 respectively. Finally, we increment index to 1. We've completed the merging of the two lists that we passed into the merge function. We've effectively replaced two elements from list of items with 1 and shuffled everything else down one spot. We now check if we need to enter the inner nested while loop again. So remember, that's index is less than leng list of items minus 1. Well, index is currently 1. Leng list of items minus 1 is 2. 1 is less than 2 is true. As the condition is true, we enter the while loop. We now call the merge function for the second time, passing in two lists as parameters as part of the function call. Now index this time is currently 1, so we're going to be passing in list of items 1 and list of items element 2. These lists are copied into the lists of the merge function, list 1 and list 2, as they're passed in by value. So we're back inside a new copy of the merge function, so once again we initialize the three local variables shown here. We now check if we need to enter the while loop. Now we're going to speed up some of these explanations here, but effectively we can see that both parts of the while statement are true, and as they're both true, we enter the while loop. We now check which part of the if-else-if statement we have to execute. Index 1 and index 2 are both currently 0. So it's the first part that's going to be true. Delaware is greater than Alabama. As the first condition's been met, we enter the first part of the if-else-if statement. We now append the contents held in list 2 index 2 to new list. As index 2 is 0, we append Alabama into new list, and we also increment index 2 to 1. We fall back to the while loop and check if we need to enter it again. This time when we evaluate the expressions, we find we have a true and a false. So as both conditions are not true, we're done with the while loop for now and move on. We hit another if-else-if statement and we check which part we need to enter. Well, it's the first condition this time which has been met, so we enter the first part of the if-else-if statement. We now hit an inner nested for loop which executes for range index 1 to leng list 1. This means range 0 to 1, and in Python, remember, this means values 0 to 1 but not including 1. And effectively this means the for loop will execute once and append Delaware from list 1 to new list. We once again have reached the end of the merge function and return new list back to the original part of the main program that called it. Again, in doing so, the function's local variables lose scope and cease to exist. We now assign a copy of new list to list of items index. As index is 1, we copy this new list into list of items element 1. We now delete element index plus 1 from list of items. That's index plus 1 is 2, so we delete list of items element 2. And finally we increment index to 2. We've completed the merging of the two lists again that we just passed into the merge function, and we've once again replaced two elements from list of items with 1 and decreased the overall size of the list by 1. We now check if we need to enter the inner nested while loop again. So index less than leng list of items minus 1. Well, index is 2 and length list of items minus 1 is 1. So 2 is less than 1 is false. So as the condition is false, we're now going to fall back to the outer while loop. We now check if we need to enter the outer while loop. There's just one condition that has to be met, and that's leng list of items is not equal to 1. Well, it's 2. 2 is not equal to 1 is true. The condition's been met, so we're going to enter the outer while loop. We assign index to the value of 0, so we've reset it because we've fallen back to the outer while loop. There is one condition that we have to check to see whether we're going to enter the inner while loop. Index less than length list of items minus 1. Index is 0, the length of list of items minus 1 is 1, 0 is less than 1 equals true. As the condition is true, we enter the while loop. So once again, we're going to call the merge function, passing in two lists as parameters as part of the function call. Now index is currently 0, so that means we're passing in list of items 0 and list of items 1. And once again, these lists are copied into the local list of the merge function list 1 and list 2. Once again, we find ourselves back inside a new copy of the merge function, and we once again initialize the three local variables. We now check if we need to enter the while loop, and as you can see here, both parts of the AND statement are true, and as both conditions are true, we enter the while loop. We now check which part of the if-else-if statement we have to execute. Both index 1 and index 2 are currently 0, so it's the statement Florida is greater than Alabama, which is true, so we enter the first part. We now append the contents held in list 2 index 2 to new list. As index 2 is 0, we append Alabama into new list, and we also increment index 2 from 0 to 1. We fall back to the while loop and check if we need to enter it again. We can see, unlike the previous time we were doing this, we do have to enter it again. We've got 0 is less than 2 is true, and we've got 1 is less than 2. Well, that's still true, so we go back into the while loop again. Once again, we check which part of the if-else-if statement to execute. Now this time index 1 is 0 and index 2 is 1. So the statement that's true is Florida is greater than Delaware. That's true. The first condition's been met, so that's the part of the if-else statement we enter. We now append the contents held in list 2 index 2 into new list. Well, index 2 is now 1, so this time we append Delaware into new list. And again, we increment index 2 from 1 to 2. Checking if we need to enter the while loop another time, we now find we have a true and a false. So as both conditions are not true, we're done with the while loop for now. We now check which part of the next if-else statement we have to execute. We've got 0 is less than 2 equals true and 2 is less than 2 equals false. So it's the first condition which has been met, so we enter the first part of the statement. We now hit an inner nested for loop which executes for range index 1 to leng list 1. Well, index 1 is 0 and the length of list 1 is 2, so this time it's from range 0 to 2, which in Python means from 0 to 2 but not including 2. Effectively, this means the for loop will execute twice, and it appends Florida and Georgia from list 1 to new list. We've once again reached the end of the merge function and return new list back to the original part of the main program that called it. And again, as before, the function's local variables lose scope and cease to exist. Back in the main program, we now assign a copy of the new list to list of items index. Index is 0, so we copy new list into list of items element 0. We now delete element index plus 1 from list of items. Well, index plus 1 is 1, so we delete list of items element 1. Finally, we increment index to 1. We've completed the merging of the two lists we passed into the merge function. We have once again replaced two elements from list of items with 1 and decreased the overall size of the list by 1. We now check if we need to enter the inner nested while loop again. Index is less than length of list of items minus 1. So that resolves to 1 is less than 0, which is false. The condition is false, so we're going to fall back to the outer while loop. We check if we need to enter the outer while loop. There's just one condition that has to be met. And for the first time, that condition is now met. Finally, 1 does equal 1. This tells us that list of items contains a single list, and therefore we know it will be sorted. As the new list is now sorted, we can do whatever we like with it. We might pass it into another function. We've added a simple print line here to output the contents of list of items 0 so the user can see the algorithm has worked. So let's consider a couple of final thoughts about the merge sort before we end this video. While it is more memory efficient to implement the merge sort using iteration alone, the algorithm can be optimized for parallel processing using recursion, and we learned about that back in SLR26. You can see the recursive calls shown here in yellow. Now clearly this is a very different coded approach from the iterative version we've just shown you, but is still a perfect example of a valid merge sort algorithm. Yet again, this illustrates our point that one algorithm can have many different implementations. Having watched this video, you should be able to answer the following key questions. Can you successfully implement a merge sort using a high-level programming language of your choice? And do you understand how a merge sort works? And can you trace its code to explain this? We know that getting to grips with data structures and all the algorithms associated with them is a very tricky area of the course, and so we've produced a book called Essential Algorithms for A-Level Computer Science that's available on Amazon. It covers all the data structures you need to know about, along with the algorithms you need to perform on them, and it covers all the exam boards. We overview each data structure, discussing its typical applications and the operations you can perform on it. We provide a QR code that jumps off to a useful page of additional resources. We then take each data structure and the algorithms you need to perform and present them first in simple structured English, then in a diagrammatic format, then in pseudocode, and finally we present you with fully coded algorithms which you need to cover on the data structures in both Python and VB so you can actually code them up and practice them yourselves.